Yeah, so today I'll be talking about our work and how we use gait as a diagnostic tool. And specifically, we use it to characterize physical and cognitive impairment. So when I started out, my research goal was really focused on lower extremity injuries, specifically anterior cruciate ligament injuries or ACL injuries. And so what was interesting about this, I probably got into it because growing up, I played a lot of sports, specifically soccer, and ACL is a big injury mechanism in soccer. So what we recognize is about 250,000 ACL injuries occur every year in the United States alone. And what we recognize is that we spend about $1.5 billion on post-ACL treatment and rehabilitation care. So it really is a problem on our healthcare system, a burden on it. And what was really staggering to realize is that fact that about 44% of post-ACL reconstruction individuals actually do not return to their previously functional level. So despite all of our treatment and rehabilitation, nearly half of these individuals do not get to where they were before the injury. And so we have to figure out, well, why is that occurring? We're doing all this rehabilitation. We're putting all this effort into this. Where's the disconnect? And so that's where a lot of the ACL research is coming in now, and where we wanted to plant our flag is the fact that we wanted to say, we think that we need to develop better metrics to actually characterize healthy gait patterns. And so that was kind of where the impetus of our work started. So whenever you start a job and you have a research laboratory, you have to have research goals. And so we had established our research goals, and these were the three items that we thought we were going to get into. And so the first one was developing automated injury classification models. So we wanted to figure out, hey, can we develop new models that are not only going to classify between healthy and abnormal pathological gait conditions, but also can we actually predict injury, right? So we're going to develop these great models, and it's going to be perfect. And then the next thing we were going to do is we were going to say, hey, we're going to do some movement optimization, right? We're going to not only, identify that you're hurt, but we're going to actually fix you and develop new rehabilitation protocols that are get you to working better than ever. And then the third thing is we were going to develop these intelligent biofeedback, systems that's going to able to get you back to where you need to be. And again, starting out, this is about 5 years ago, you recognize that you have these lofty goals, and then you have to figure out how you're actually going to solve them, right? And I think it was also naive because we're like, oh, we're going to develop these models and we're going to develop these rehabilitation protocols. And, it's only going to take a year or two, right? I mean, this is easy.
And then the models are going to learn other models. And by slide 3 on a podcast 5 years in the future, it'll be a 3-slide presentation saying it all worked out at the end.
100%. That's exactly where it is. You've watched enough of these TED Talks and presentations. That's how it works out. And when you quickly get into this system, you start to realize that, okay, we want to develop these classification models. Well, what are the metrics that you're going to use that are going to be better than what people have done before? And you go, that's going to take a little bit more time than we thought, right? And then you go, we're going to develop these novel rehabilitation protocols. And you go, well, people have been doing this work for decades. They've been really good. So what are we going to do that's different? What's your idea? And I go, don't really have one right now. And then, you go, we're going to develop these novel rehabilitation instruments. And you go, that would be great, but I have no skills in some of these areas. And more importantly, what we talked about is like life. We planned to do this podcast a year and a half ago. And what you plan and what happens are very different. And our third study, we talk about, we got into getting into cognitive work. And at no point in my life did I think I was going to be cognitive work. So, this slide, I love it because it identifies that you need to have goals, but I kind of laugh because you need to be somewhat realistic and recognize that your goals and plans are going to change.
Yeah, I would say that very quickly, even looking at this slide, the scariest thing on it is still that double integral right behind that first skeleton. That's the one to really look out for.
Oh yeah, we don't talk about that double integral.
It's gone. It's like we just optimized. No integration. All right, cool.
Yeah. So to do all this work, we had to have the facilities and equipment to do so. So we have a human performance lab that the University of Connecticut was really great in allowing us to provide the funding to get us up and running. And so running. But what we have is, it was really kind of a cool is that we have state-of-the-art equipment. We have a Vertec instrumented treadmill, and you'll notice that is a split belt treadmill so we can control each limb independently. We also have a Vicon motion capture system. We have a 12-camera system. And what's great about this 12-camera system is, have you ever done like video games and you've seen the people, they put on the spandex and they put the dots on them and they run around? That's the same technology we use in our lab. So here's just a video. So we wouldn't necessarily put a marker on a shirt. It moves. but for thematic purposes, it works. So we have this really cool setup, and we marker the individual. We put the markers on the anatomical landmarks. We also put EMG so we can measure muscle activation. And typically for men, we would shave your legs. So a lot of men come out looking very patchy after they do these studies. But then it's great. So we put all the stuff on there, and then we actually get you on our treadmill, and we have you do this motion analysis. So here's what you would look like, fully markered up. And then what's great is our Vicon capture camera is going to allow us to see you, give you a 3D rendering of your movement in real time. So that's kind of the fun stuff. So we always think that we're playing a lot in lab, that we get to do all this work. So now that we collected all this data, we had to figure out, well, what do we want to analyze? And so, like I said, we use GAIT. And GAIT is a great tool because GAIT requires a coordination of the musculoskeletal and neuromuscular systems. And so the idea is that if you have pathological GAIT, it's going to disrupt either one of those systems. And so those changes are going to manifest in your GAIT patterns. And so that's why we looked at GAIT. And additionally, it's non-invasive. A lot of the GAIT measures we can, collect them non-invasively. So things like stride time and ground reaction force and knee angles, all that stuff can be measured non-invasively. So unlike blood work, which is still minimally invasive, you collect blood and you do a lot of kind of tools and tasks on them and analysis on them. We do the same thing with GAIT, but we don't go, we're not invasive by any means. So so one of the things is we'll start to get into the study. So we looked at GAIT and we're really excited. But the first study, like we said, going back to our main theme was, well, let's develop new metrics that can quantify optimal GAIT patterns. So we all walk, but if you go to any kind of GAIT analysis lab and you say, well, what should my optimal ground reaction force be for when I walk? And we wouldn't really have an answer for you. What should be my optimal loading rate for, when I'm running? We don't have an answer for you. A lot of our studies, we take a population of healthy individuals, we take a population of pathological individuals, people with pathological conditions, and then we just kind of say, oh, well, in this group, your loading rate was higher. And that's great. But if you're coming from a clinical standpoint, physical therapist standpoint, you go into physical therapy and, you want to get somebody back to healthy. We can't bring in 20 other individuals, healthy individuals, and say, hey, how do you match up against them? So our work was trying to figure out, can we define optimal regions of GAIT dynamics that we could use kind of as a clinical tool? Then the next thing we wanted to do is we want to develop our novel rehabilitation protocol. So again, now that we know what your healthy diagnostics should be, can we develop some rehabilitation that's going to move you into these healthy regions? And then the third thing was kind of our derailment, where we started to look at the differences between physical and cognitive impairment.